let's say over here, this is a horizontal frictionless surface. This is pulley, string is going like this, string is horizontal, 5 kg block, 15 kg block, and this is vertically hanging. All the surface, they are frictionless, it's ideal conditions. The strings, they are ideal, and over here the pulley, there is no, this massless pulley, and there is no friction between the axle and this pulley. We are asked, what is the velocity? Suppose this is released from rest, this 15 kg block is released from rest, with what velocity this is going to strike the floor. So let's first of all do it our usual method, that is dynamics principle, that is let's use laws of motion. Laws of motion when we use, then we say onto this whole body, the only force which is trying to move the system this way is mg, that is 150 Newton. Had this block been not there, this would have been remained stationary. So 150 Newton, because of 150 Newton, net force is 150 Newton, and this force is responsible for accelerating both the masses, 15 plus 5, 20 into A. So A comes out to be 15 by 2 meter per second square. And if we have to find what is the velocity with which this strikes the floor, it is v square minus u square. Initial velocity over here is 0, over here v. 2 into A is what? 15 by 2. S is what? 2. So this comes out to be, v square comes out to be 30 meter square per second square. So v comes out to be root 30 meter per second. Now let's do it on the basis of energy principle, conservation of energy principle. We have done it using laws of motion, and now we are doing it by using the energy conservation principle. We say, let's take this body as 1, so it's potentially 1. We say kinetic is 1, we are bothered about potentially 2, and we are bothered about kinetic 2. And we are doing on the basis of losses is equal to gains. Onto this system, there is no friction forces, there are no air resistance, etc. All the forces, they are conservative forces. Then it means we can use the principle of conservation of mechanical energy. It means there may be some changes in potential energy or kinetic energy, but all the changes, the whole energy remains within this system, that is within the two blocks. The whole energy will remain with the two blocks. It is maybe that is potential increases or kinetic increases, but the sum total of potential energy plus kinetic energy with these two blocks, that will remain same, and that is what we have done in conservation of mechanical energy principle. So let's say when the body goes from here to here, we are interested in what are the changes. We are not taking this as reference level to make the things easier. We are directly get into, that is what are the losses and what are the gains. So if we talk about the potential energy over this, the body has gone down. When the height has reduced, then obviously the potential energy reduced. So there is a loss. What is the loss? That is 15 G into 2. That is the loss. Kinetic energy of this block 1. So when it has gone down, over here the velocity is 0, over here the velocity is v. It strikes with the velocity v. So velocity has increased. So kinetic energy has been, there is a gain of kinetic energy. So half into 15 into v square. That is a gain. So these two terms, potential energy, kinetic energy of mechanical energy of this block number 1, they are dealt with. Now we come to this one, potential 2. This has, when it has come over here, this remains at this level only. We are not talking about that this strikes and comes over here. This is sufficient length. So there is no change in potential energy. So there is no use of talking what is the change in this potential energy, it remains same. Kinetic energy 2. When this is velocity 0, this is a string, this is inextensible string. So if its velocity, whatsoever the velocity of this block, the same will be velocity of this block. So initially it is 0, its velocity 0. When it strikes with the speed v or velocity v, it is also going to have velocity v. So velocity gain, speed gain. So gain is half into 5 into v square. This is a loss, this is a gain. Losses should be equal to gains. So it means 15 into g 10, we are taking for convenience, we are taking it as 10 meter per second square. So into 2 is equal to half 15 v square plus half 5 v square. It is going to be half 20 v square. So this is, so once again, that is, this is going to 10, so this comes out to be 30 is equal to v square, and v comes out to be root 30 meter per second. We get the same answer. Now we do it by work energy theorem. If we do it by work energy theorem, so let's see over here, when we say work energy theorem, we have done by laws of motion. we have done on the basis of conservation of energy principle, and now let's understand it by using work energy theorem. So this is 15 kg, this is 5 kg block over here, frictional surfaces, and this is 2 meter. Now thing to understand is what is the net force which is responsible for moving this body, moving this system. It is only 150 Newton. Had this body been not there, then this would have remained stationary, and this is vertically hanging, this is not at an angle. So we need not take any components, there are no components, this is only 150 Newton only. So 150 Newton is here. So work energy theorem, that is, so what does work energy theorem? It says that is work done by the net force is equal to delta K, which is equal to kinetic energy final minus kinetic energy initial of the system. So work done by net force is equal to this thing. So what is the net force? Net force is 150 Newton. This is 150 Newton, displacement has also been in this direction. 150 Newton is in this direction, displacement is also in this direction. So F into S, S is 2 into cos 0 is 1 is equal to kinetic final is half. Whole system goes with the velocity v. What's the velocity v? Same velocity v. So the total mass is 15 plus 5, half into 20 into v square. So this is 150 into 2 is equal to half into 20 into v square. V square comes out to be 30 meter square per second square. V comes out to be root 30 meter per second. All the answers they match.